Identify the height of the triangle if A is the base. So by looking at this picture, we're talking about a triangle, but we can see that there's definitely more than 3 line segments. So it can be a little bit confusing when you first take a quick look at it. So one thing to note is that we have these dashed lines here, and these dashed lines are not a part of the triangle. They give us information, but it doesn't make up the actual size of the triangle. So a triangle is 3 sides, and the 3 sides are formed here. So one thing you can do is, if you get confused, you can look at for the solid line segments, and we know that those are that make the sides that make up the triangle. So what I'm going to do to make it a little bit easier for me is I'm going to redraw this on the side or underneath it. So here's one of the solid lines, so I'm going to try to recreate that. Then we have another side here, so I draw that, and then the third side goes from here to here, so I connect those two, and that's the triangle that we're actually talking about in this picture. And they wanted us to identify the height of this triangle if A is the base. So I'm going to make sure that I consider A to be the base of the triangle. And I can see A is on this side here, so that's this side. So here's what I want to consider to be the base. Now, to make things a little bit easier for me, I'm going to rotate the triangle such that the base is on the bottom. Alright, we're going to rotate this such that the base A is on the bottom now. Alright, so now I have that as the bottom, and I'm going to put A down here. So I just took this figure and I just rotated it so that A is the base or the bottom of my triangle. And if you want to identify the height of your triangle, what you need to do is look for the vertex that is not on the same side as the base. So think of the vertices as the intersection point for any of the sides. So here's one of the vertices, here's another one of the vertices, and here's my third vertex. And just so you know, vertices is plural for vertex. So the vertex that's not on the same side as my base would be this vertex up here. And if I wanted to get the height of this triangle, well, the height of a triangle is basically you have to measure it directly down. So I can draw a dashed line that goes straight down to the base. And one way that I know by looking at a picture if this is the actual height is that, for one, it connects to the vertex, and you'll also notice that it'll be a 90-degree angle formed with the base. So this dashed line and then the base forms a 90-degree angle, also known as perpendicular, and that lets us know that this is the height of our triangle. So if I were to identify the height of the triangle, I have to go back to the original image, and I gotta say, okay, which one of these dashed lines is coming away from the vertex, and it goes to the base with side length A, and it also forms 90-degree angle. Well, if looking at the image, I can only see 2 dashed lines. The dashed line here is C, and this one is E. But if you look at E, it does not form a 90-degree angle with the side A. And I can see that the length of this segment, C, forms a 90-degree angle with side A. And it also connects to the vertex, therefore I know that the height of this triangle would be C. So I'll say C is the height of the triangle.